Kindly hit the subscribe button. Thank you. Alright guys, today I'll be treating the examples in EEE 231 chapter 1. Alright, so example 1.1. Alright, so we have y equals to cos x square, and this is another function of function. Now in function of function, we already know that we have if y equals to f of u and u equals to f of x. Now, well, just to put everything, to simply put, we can easily say that dy dx is equals to dy du multiplied by du dx. It's still the same thing, because if you say du cancel the du, that's dy dx. So we have y equals to, our question is y equals to cos x square. Then our x square, we can say u equals to x square. I want to say u equals to x square. That means our y is now equals to cos u. So in this context, we are going to find the derivative of y. That means dy du. We're going to differentiate y in respect to u, and that will be cos u. Okay, in short, I will quickly give us a short distance. You have sine here, you have cos here, you have minus sine, and you have minus cos. So when you differentiate your sine, it gives you cos. When you differentiate your cos, it gives you minus sine. And when you differentiate your minus sine, it gives you minus cos. Alright, so we have dy du equals to, our cos is minus sine. That will be minus sine u. Also, to differentiate, we formally said that u equals to x squared. So we have to differentiate u also in respect to x, and that will be du dx equals to our x squared. That will be what? 2x. Now, just like I told you, I said that dy dx is equals to dy du multiplied by du dx. And what is that going to be? That will be dy du is what? Minus sine u multiplied by 2x, which is du dx. And since we've done that, that means we can easily say that that will be minus 2x sine u. Don't forget, what is our u? Our u is x squared, and that will be minus 2x sine x squared. This is the derivative of y equals to y equals to cos x squared. Thank you. Alright, so that is that. Example 1.2. Example 1.2. So we have, the question is y equals to exponential 3x sine 4x. This is under the product rule, and if you remember the product rule, that is dy dx equals to u dv dx plus v du dx. So, and our u equals to exponential 3x and our v to be sine 4x. When you differentiate your u, that will be du dx equals to 3e exponential 3x. We should have known that. Then our v is dv dx equals to, when you differentiate your sine 4x, for the sake of, when you differentiate sine 4x, that will be 4. Now, when you differentiate your sine, it gives you cos 4x. This is it. This is just like the first one we did, and that is like function of function. So when you differentiate this 4x, it gives you 4. When you differentiate your sine, it gives you cos. Then you replace this, you put this back, that will be 4 cos 4x. Alright, so after that, let me just do this. Okay, so after that we say dy dx dy dx equals to du a sorry u, that's for function of function, that will be u dv dx plus v du dx. Now our u, we already know our u is exponential 3x from this place. It's exponential 3x, and that will be exponential 3x multiplied by our dv dx. From here we know that it is 4 cos 4x plus our v is sine 4x, and our du dx is 3e exponential 3x. Now from there we can also say that, alright, that will be, when we multiply this together, that will be 4, we can easily say 4e exponential 3x cos 4x plus 3e exponential 3x sine 4x. This is still like the same thing. Now we can we see that exponential 3x is common to both sides, so we can easily say exponential 3x open bracket 4 cos 4x plus 3 sine 4x, and that will be all for that now. Alright guys, example 1.3. Example 1.3. Okay, so we have x raised to power 4 over x plus 1 raised to power 2. Raised to power 2. Okay, now to differentiate this, okay, what we are going to do is we make this as our u, we make this as our v. Now after that, the formula for quotient is what? V du dx minus u dv dx all over v square. Alright, we should know that our u now is x raised to power 4 and our v is x plus 1 square. Now the differentiation of our u in respect to x, that will be what? 4x raised to power 3, and the differentiation of our v in respect to s, that will be 2 open bracket x plus 1 square. Alright, so we can now say our v here is x plus 1 all square open bracket du dx, which is 4x raised to power 3 minus our u is x raised to power 4 open bracket, our dv dx is 2 open bracket x plus 1 square, everything all over v square. Our v is x plus 1 square, everything all square. Yeah, so after that we can now simply say that x plus 1 all square bracket 4x raised to power 3 minus x raised to power 4 2 bracket x plus 1 square. Alright, for it will be quite better and easier if we can just split this into 2, x plus 1 square. Alright, now we have x plus 1 square here, we have x plus 1 square here, we also have x plus 1 square here. And what is that just trying to say? We can simply say that x plus 1 square open bracket 4x raised to power minus 3 minus 2x raised to power 4 all over x plus 1 square x plus 1 square. This therefore cancels this, and we now have 4x raised to power 3 minus 2x raised to power 4 all over x plus 1 all square. That is all on that. We'll move on to example 1.4. Alright, so for your example 1.4, I've solved that before. That's another logarithm differentiation. Now we'll move on to example 1.5. If x square plus y square minus 2x plus 2y equals to 23, find the y, the x, and the square y, the x square at the point x equals to -2 and y equals to 3. Now from here we can just say that, let's just differentiate this. That will be 2x plus 2. When I differentiate with respect to what, that will be 2y the x minus 2, our x is gone, plus when I differentiate these two, that will be 2 dy dx equals to 0. Now from there, let me pull these two together. That has the y dx, that's just like collecting like times, and that will be dy dx open bracket 2y minus 2 equals to, when this comes here it becomes 2, when this comes here it becomes minus 2x, and that will be dy dx equals to what? 2 minus 2x all over 2y minus 2. Oh, sorry, this should be addition, this should be plus. Yes, this should be plus and this should also be plus. Yeah. Now, we already know from the question that our x equals to -2 and our y equals to 3. So we can now say that okay, dy dx at x equals to -2 and y equals to 3, that will be 2 minus 2 open bracket minus 2 all over 2 open bracket 3 plus 2, and that will now give us what? 6 over 8, and that will be 3 over 4 when we differentiate, when we divide to the lowest term. 2 in 6, 3, 2 in 8, 4, that's 3 over 4. Now from there we can also go forward to the second derivative, that's the square y over the x square. Now we need to understand that ddx of my dy dx, and my dy dx is already what? 2 minus 2x all over 2y plus 2. Yes, all over 2y plus 2. And based on that, we can equally say that these now we are going to be differentiating it by using quotient method. Using quotient method. That will be 2. Our u is now 2 minus 2x, and our v is now 2y plus 2. Our du dx is now -2, and our dv dx is now 2 dy dx. Yes, is now 2 dy dx. Now based on that, you can equally say the formula for the quotient rule is v du dx minus u dv dx all over v square, and from there we can still say that our v is already 2y plus 2 open bracket my du dx, which is -2, minus u. My u is what? 2 minus 2x. dv dx is 2 dy dx all over v square. Where is my v? And that will be 2y plus 2 all square. Now after that, we should now know that, okay, let's just substitute the values here. Let's just substitute the values. That means the square y, the x square equals to 2. Now the square y, the x square at what? At x equals to -2 and y equals to 3. That means that will be 2 open bracket. Our y is 3 plus 2 then open bracket -2 minus 2 open bracket. Let me use a parenthesis bracket. 2 minus -2. X is what? X is -2. X is -2 and 2 dy dx. What is dy dx? Our dy dx is 3 over 4. So we can simply say that 2 here 1, 2 here 2. Yes, that is on that. Now everything all over 2 open bracket 3 plus 2 all square. And from there we can now say 2 times 3 is 6 plus 2, 8 times minus 2. That will be minus 16. That will be minus 16 minus minus times minus 2 is plus 4. 2 times 4. 2 times minus times minus 2 is plus 4. 2 plus 4 is 6. 6 times 3 is 18 all over 2. That will be 9 all over 2 times 3, which is 6 plus 2, 8 square, that is 64. And therefore our final answer is minus 25 all over 64. Thank you. Kindly hit the subscribe button. Thank you.